Okay, so this is the mechanical template. Let's get rid of this. Let's work with the architectural discipline. Okay, so I'm in the mechanical discipline. So if you open the architectural discipline, we can make it bigger. I want a rectangle, so I was using a square, and now I want to use a rectangle. Okay. And now, once I'm done with the walls and roofs, then I go to the mechanical discipline, and now the walls and roofs are not available. Okay, so I remember that I had all these pipes here, so I need to rotate this 180, so that for the air handling unit, I have all these pipes here. And now this is the supply, and that will be the return. What are we going to do first? I will work with the air ducts again very quickly, because we devoted the lesson to explain the air ducts, and then there was another lesson in which we changed the area of the air ducts so that we can adjust the airflow and the velocity. And because at the end, I have to check that we have the right airflow, we have the right air velocity through all the ducts, and what else? And everything's connected well, okay? Because if things are not well connected, then the airflow will change or will be zero in one of the ducts. And that means that there's something wrong with the connections. So today we will do it again very quickly, but applying the right sizes so that when we check this, it will be correct. Because last time we did the duct work, and then we checked the air velocity, and we found out that it wasn't correct. Today, we will start thinking about the right size, and then we will model with the right size, and the velocity will be the right one. But I want to do something new today, which is we want to include the other systems. So you remember that in the assignment, we have two options. We can either use a ground source heat pump, or the other option, we had to use a water-cooled chiller, a boiler, and a cooling tower. Okay, so if you know how to deal with this, this is the most complicated schematics that we might find. It's not the most efficient one. Actually, I don't like cooling towers, and I don't like it. Anyway, it's not the most efficient one, but it's the most complicated. So if we can design the most complicated system, then other systems will be a piece of cake. So we are going to design the most complicated one with a boiler, a water-cooled chiller, a cooling tower, and the air handling unit. So essentially everything has to be connected to the air handling unit at the end, and then the ductwork with the air ducts. So if we know how to do this, we know everything about the REVIT mechanical template. So let's do it. So we have to insert families. We have to go to this US Imperial, and we have to go to the mechanical MEP. We connected airside components. Basically, those are air handling units, the airside components, and the air terminals, and so those are the air handling units, the diffusers, okay? But now we have to go to the water side components. So on water side components, we have boilers, chillers, and cooling towers. We also have pumps and tanks, and probably, so here we have the pumps, okay, to pump water. We are not going to do this today. Today we're going just to work with boilers, chillers, and cooling towers. So let's select the boiler. We don't have pellets boiler here. I know that in the assignment it was a pellet boiler, but when it comes to the schematics, It's the same. Okay, so there's a way to upload different families, but we will explain that later. Today, let's work with the default things. So we can use the condensing boiler, because a condensing boiler is the most efficient gas boiler that we can find. So we are going to use a condensing boiler. We open. What else? These are the boilers. Then we have to work with chillers. So with chillers, there are a lot of options here. Which chiller should we select? Well, we have water-cooled and air-cooled chillers. There are others, but this is what we have studied, the water-cooled chiller and the air-cooled chiller. The air-cooled, we have two options here. Well, we have more air-cooled chiller, but look at this. Those tons are represent the size of the chiller. These are too big. I mean, we can insert those, but this is 80 to 350 tons. This is 400 to 500. This is 20 to 55 and 60 to 120. So I would use these two coolers. Okay, these two air-cooled chillers. And I want the water-cooled. So this is 74 to, but I don't like this one. Okay. Let's select this one. It's the water-cooled 300 to 550 tons. Let's open this. There you go. And what else? We need a cooling tower. So we have the boiler, we have the chiller, now we need a cooling tower. So again, what cooling tower should we use? This is 37,200. This is 140. This is too big. This is too big. Okay, let's select the smallest one. This one. It's 37,200, and the rest are higher. Okay, so let's select this one, the first one. Okay. So now we have everything. We have the chiller, we have the boiler, we have the cooling tower, and we have the air handling unit. So we have to insert different things, and then we have to connect water pipes. So connecting water pipes, it's quite easy. The problem is that depending on what we are doing or what Revit version we're using, we might load pipe connectors. I don't know. So so here you see this is 1.5 inch, and this is out, this is out. If we move this, okay, so we are selecting so this is out, this is in, so this is a coil, and this is out, and this is in, so this is another coil. If you have this symbol here, that means that this is a closed loop, but with this symbol means that this is a drain, okay? So this is not a closed loop, so there's an out here, outlet, and we will get rid of the condensing water that we might find in the air handling unit, so we need to get rid of this water here, but we need to work with closed loops here. Okay, so this is the cooling coil, and this is the heating coil. How do I know that this is the cooling and this is the heating coil? When we have this to get rid of water, this is the cooling one, because the water cools down in the cooling coil, and the water condensates in the cooling coil. Okay, so when we have this this coil with three inlets or outlets, 1, 2, 3. This is the cooling coil. If there are only 2 of them, this is the heating coil. Okay, so this is heating, this is cooling, and this is a closed loop. So this is the water inlet, the water outlet, And this is a water outlet, but this is to get rid of condensing water we can have here in the cooling coil. And what else? Oh, yeah. So imagine that I right click here and I'm throwing a pipe. So I throw a pipe and then I want to, okay, it doesn't let me do this. Why? Because there are no elbows. So I haven't loaded anything, any family about pipes. So we have to load now it's not mechanical. We have a folder here with pipes. Okay, so let's do this. We have a lot of things here, fittings, valves. Today we're going to work with fittings. So select fittings and let's work with generic. I don't know, if you become a plumber, people that make a living just by welding and connecting pipes, you will earn a lot of money, probably more than if you are an architect. But well, you have to wake up earlier and probably you have to work when it's too cold outside. So they deserve what they make. Okay, but well, I mean, being a plumber, you know the difference between the carbon steel, the gray iron, the malleable iron, the PVC, steel frames. Okay, so those are different materials for the plumbing system. Usually for heating and cooling pipes, we use copper or copper. Yeah, copper. Or now we use plastic, PVC or something like that. So things are changing. Carbon steel. Maybe at the beginning of the 20th century, plumbers were using, well, the plumbers, they are plumbers because they use lead. So plum boom, it's the Latin word for lead. Okay, this is lead, this metallic, or this metal, gray metal, and lead pipes. So those are lead pipes. So those were very common at the beginning of the 20th century and yeah, even until the 50s. But this lead, which is plum boom, okay, so plum boom is lead. So that's why the plumbers are plumbers, because they usually or they used to work with lead, with this material. Okay. I can teach you Latin, but not today. Okay, so plumbers usually used lead. Now lead, it's not healthy, so all the lead pipes have been replaced by what? Copper, probably. Carbon steel pipes. This is too old. Yeah. Well, you might find some of those, but steel pipe carbon, I think it's too expensive. So probably you might find something like that, but in single family houses, you won't find carbon steel pipes. They are too, I think they are too expensive. So we can use copper. Okay, so this is the typical color of copper. And but now we use X pipes. Okay, now we use plastic. Okay, so the plastic, we have the blue one for the cold water, the red one for the hot water, and the white one for, I don't know, for something else. So there's a lot of advantages using because you don't have to weld it. So you need these connectors, but they are flexible, so you don't need to have elbows. And so if you don't have exposed pipes, the plastic is the better option. It's much more, it's much cheaper than the copper or the steel or the lead. Okay, so it's flexible, it's easier to connect. So now plumbers, they don't use lead anymore. They don't use copper. They don't use steel. They use plastic. Okay, so it can be either PVC. The gray ones are made of PVC. They are usually for drainage, but those red and blue ones are PEX, which is the polypropylene. Well, it's a polymer. I don't know exactly. So PEX, it's the commercial number. It's not the technical. It's a commercial name. It's not a technical name. But anyway, those are plastic pipes. Anyway, here we have carbon steel. We have iron. There are malleable iron. It's something. We have PVC. This is the plastic. We're going to use a generic one. Okay, so we are not plumbers yet, but maybe in another life I will be a plumber, but not in this one. But we are going to use the generic ones. Okay, so we are not concerned about the material. We are just connecting things. So let's select everything, because here we have elbows, we have elbows, T's, transitions. So let's select everything and let's open this. Okay, does it work? If I have uploaded the connections, can I make another pipe? It doesn't work. Okay, so finally, this is the worst case scenario. Probably in your Revit version, you can draw the pipelines without doing everything I'm doing now, but just in case. So if it doesn't work, then you have to edit pipe. So you have to edit pipe. We have to select the routing preferences. And yeah, this is what I was thinking, that we don't have anything here. So we have none, none, none. So we have to change this. So let's select the generic standard, because we have uploaded the generic standard, okay, for the elbow. And here for when you can see none, the pipes are from 1/2 inch to 24 inches. So 1/2 inch is something very like this, 24 inches. It's so here we can select all. So that means that those connections are for either 1/2 inch or to 24 inches. So for junction, select the T generic standard. So everything that is generic and it's standard, it's okay. Here we have to select all, everything generic standard, all, transition, generic standard, and all, union, and cap, generic standard. Okay, so if you select here, usually by default, everything is like this. It's generic standard, and it's by default, everything's like that. In my version, it's not. I don't know why. But I'm sure that if you go to the TDS center, all the you will have these options like this with a generic standard. So we click OK. We have to apply. Apply, yes. And I hope that if I draw a pipe now, there you go. Okay. So now we have the elbows and we have all fittings here, and we can work with it. So let's get rid of it. Well, now this is fun actually. At least now it's fun to me. But let me go to the east elevation or the north elevation. No, the east is better. Okay, so this is the okay, let me change this. This is just to clarify myself. Instead of having level 0 at the 0 level, I like to name this, if it's 0, that's level 0. That would be level 15. And that will be level 30. And that will be level 31. There you go. Okay, so we have 2 floors here. I don't know. We should have a basement, but I'm going to place those equipment not in the basement, but on level 0. Okay. So on level 0, if I open level 0, I have to place systems, mechanical equipment. I have a cooling tower, but the cooling tower is on the roof. Now, on level 0, we should have the condensing boiler. And this is the size of this condensing boiler. Let's take 1,000 and place the boiler on level 0, elevation from level 0, 0. So let's place it here. Okay. And now, mechanical equipment. What do we have on the basement, or in this case on the first floor? We have the chiller. So here we have the water-cooled chiller, and let's select the smallest one. And the smallest is something huge. Okay, in, out, in, out. Okay, so we have a chiller and the boiler on the basement, or yeah, the basement. And we need a cooling tower. But let's analyze this first, and then we will place the cooling tower at the end. So first, this is the boiler. Okay, so in the boiler, what do we have? We have this out. This is a pipe, or this, well, this is not a pipe, this is a duct. And if it's a duct, this is an exhaust duct, because we have this symbol. So that means this is not a closed loop. So this is not, this is to get rid of the gases that we have on the boiler. We have a gas boiler, so we generate gases and we have to get rid of it. Okay, so this out, which is a thick duct, it's for to get rid of gases. So keep that in mind. Here we have something to get rid of water. So you see the symbol of drainage here, okay? And here we have two outlet and inlet with closed loop. So those are the elements that we have to connect to the air handling unit. Okay, so we have this, and this is 2 1/2 and 2 1/2. Okay, and here we have another inlet and another closed loop. Well, that means that we have 2 inlet here, so either here or there. Why? Well, I think both are correct. So that depends on where the boiler is placed. So we can either use those two, or we can use this one for the outlet and that one for the inlet. Well, it depends. This is a, but if we select the inlet and the outlet, that's fine. So that's another one. So probably if we can't use this because there's something here that prevents us from using this one, then we have another inlet here. But anyway, we will use these two ones, and we will connect this to this is the boiler. So we have to connect this to the heating coil of the air handling unit. So this is the cooling coil. We have 3 of them, and then we have 2 of them. Wait, where is this? Here. Okay, so now I think it should be easy. Let's select the east elevation. Okay, so on the east elevation here, this is the air handling unit, and this is the boiler. So we have to connect these two, this is inlet, outlet. We have to connect it to the air handling unit. So first, we have to go horizontally, and then we have to go up. So from this one, I can select draw pipe, and I have to go here, and then I can go up. But before going up, what is the size of this? 2.5. Okay, let's use the diameter can be 2 inches. We will learn how to calculate the diameter of water pipes, okay? But I think 2 inch, it's good now. Okay, so we can select this and then the diameter. You can change the diameter if you want 5. So you will have a thick diameter, but for these things, 2 inches is more than enough. Okay, so once we have selected this, I can go up. And if everything goes well, yeah, we have the elbow here. So remember that we have to connect this to the air handling unit. So let's go just beyond the roof level, okay? And then we have to go horizontally to connect this to that. But then from this one, we have another loop. So we can draw pipe. Here, let's make it 2. And then let's go up. Okay, so now on this level, this is what we have. So we go out and then go up, and then we have to connect this to this. But now what is the inlet and what is the outlet? Well, good question. We can start this here. We can draw a pipe. And here we can draw another one. Okay, so somehow we have to connect. This is the heating coil, and that comes from the boiler. So we have to connect these 2 pipes to these 2 pipes. And how can I tell what pipe do I have to connect with what? Okay, so if we click here, this is hydronic return. You see here on the properties windows, this is hydronic return. We can change it. Well, we can't because it's a hydronic return. And what about this? This is hydronic supply. Okay, so this is not the one I have to connect to this one. I have to connect this one. So I have to connect hydronic return to hydronic return. So by knowing this, everything is easier. So from this hydronic return, I can draw pipe. I can go this way. And now if I look at the top level, okay, so this is the hydronic return. No. This is a supply. Okay, let's work with the return at the beginning because it will be a mess. Okay, so let's move it here. Let's move it here. So now we are in the same axis. And now if we just drag this point here, oh, I love REVIT. Okay, so we don't have to worry about this because REVIT connects everything vertically with the right elbows. Okay, But there's something wrong here, because if I go here like this is not acceptable, because you see, so I'm going through one of the pipes. So that's not acceptable. What can I do? Well, that's why you need to be a plumber, because if you were a plumber, we would know what to do here. But we know that we can have crossings. So probably we will need something like this. And then from this one, we can go this way. And then if we click on the top level, okay, so at this top level, okay, so you see that this axis is highlighted, so that means that we're in the same plane, and then we only have to go this way, and REVIT connects it. Is this the best solution? No, it's not. But okay. Okay, at least we have connected the right pipes. This can be better. Yes, this can be better. That okay, the fewer fittings, the better. So here we have an elbow, we have another elbow, another elbow, and another elbow. So if there is a way to change this, we can make it. But anyway, I think it's good for the first. Yeah, the first time we try to do this, I think it's good enough. So now we have connected the boiler to the heating coil of the air handling unit. Everything's correct, because the return, well, the hydronic supply is connected to the hydronic supply, and the hydronic return is connected to the hydronic return. So that's why everything is correct. What's next? So now we have to connect the cooling coil to the chiller. Okay, so let's analyze the chiller now. So there are a lot of things in the chiller. So in the chiller, we always have an evaporator and we always have a condenser. Okay, so the evaporator, we have inlet and outlet for the evaporator, and we have inlet and outlet for the condenser. Okay, so one of them has to be connected to the air handling unit, and the other one has to be connected to the cooling tower. Okay, so let's do this. But let me, yeah, this is too big. Do we have, this is the smallest. Okay. I don't want a lot of elbows, so that's why I try that this inlet is not matching this, because I want to reduce the number of elbows and all that stuff, okay? And well, the problem with those chillers is that they are meant to be in large buildings. So this is a small building with a small air handling unit and small boiler, and we have this monster here, and these water pipes, it's 8 inches. It's too much. Okay, so let's draw pipe. Well, we have this, but we can reduce this to 2 inches. There you go. And then this one. So again, that should be 2 inches. There you go. Okay. So now we have a hydronic supply and a hydronic return. So this is the return, and this should be the supply. And then we have to connect this to the air handling unit. So from this air handling unit, there will be a pipe coming out this direction, another pipe coming out from here. Well, we don't want to connect this to this, so there you go. And now this is the return, and this is the supply. So here, what is the supply? This is the return. So now we are working with the supply one. So let's go in this direction. There you go. Then we have to go up. So from the east elevation, I can go up. Okay, but I have to go up until this. So probably I need to come here, and then I go up. Okay, and now this is supply, and this is supply. So what happens if I drag this until this point? Or I drag this here. Oh, nothing happens because they are not in the same vertical. Okay, so I need to go to the top level. And there you go. Again, am I proud of this? Not really. But, well, it works. And now I have to drag this here, and I have to connect, this is the return. So I have to connect the return to the return. So this is the return. I go in this direction. And then I have to go up. Well, sometimes if you are doing this in the 3D model, it doesn't work. So you have to go to the east elevation. If you want to go up with pipes or ducts, it's better if you use the elevation. So it's like this. And now on the 3D, okay, so we have to connect these two pipes on the top. Okay, I have to connect this to this. Okay. Well, again, it's not the best option, especially here. We are losing a lot of fittings. So there are a lot of fittings here. We don't need all this. Anyway, the most important thing is that everything is connected to what it has to be connected. So the boiler is connected to the heating coil. The chiller is connected to the cooling coil. Are we done with this? No, we're not, because we need a cooling tower. The cooling tower has to be on the top of the building. So on level 31, okay, this is where the air handling unit is. And now we need to place the cooling tower. So let's go to systems, mechanical equipment, and there should be cooling towers here. They're cool. cooling tower. Okay, again, the smallest one. This one, it's big enough. So let's place it here. Let's look at the 3D where it is. Okay, and now we have to connect the other circuits, the other pipes of this heat pump or the chiller to the cooling tower. So first we need to know where the inlet and outlets are. Okay, so for the cooling tower, we have a drain here. So this is to get rid of water. This is for water supply. So we have an inlet here for water supply because we need that cooling towers need a constant water supply. And this is the inlet and outlet. Okay, so again, from these two, we need to draw a pipe. To be consistent, let's make it 2 inches. From this one, we need another pipe. And 2 inches. And now we have to connect this to the boiler. To the boiler, sorry, to the chiller. And we need to go out. And we need to go out from this one. The pipes are huge, so let's make it 2 and 2. And now we have to go up. Okay, so probably using the south elevation. Yep. So now from this one, we have to go up. And from that one, this is too long. We have to go up. Okay, so there are 2 pipes here and 2 pipes there. So we need to connect the return to the return and the supply to the supply. This is return and this is return. Okay, so we have to connect these 2 pipes here. So we can go to the top level. And from this one, and then from that one here, connect it here. Well, oh, look at this. If you connect this, you have a T. So you see that this is not an elbow, this is a T. So we get rid of it and then we drag it and now we have the elbow. Okay. So again, is this the best option? No, it's not. I'm doing this just to let you know what I'm doing, but usually we have a shaft somewhere, usually in the corner of the building, and all the vertical pipes are through that shaft. We are not doing this. We don't have vertical pipes anywhere in the building. So there's a place to go with all these ducts, vertical pipes. Okay, so by doing this, it's difficult. It's a nightmare. So this first exercise is just to connect things. Okay, so I want you to connect everything. So the chiller has to be connected to the cooling tower. The chiller has to be connected to the cooling coil of the air handling unit. The boiler has to be connected to the heating coil of the air handling unit. Return and return, supply and supply. But now we need to fix all these things. We're not going to do this for this assignment. I want you to connect things, but for the next assignment, we should be able to make it nice in a professional way, because this is not professional. So we don't have vertical pipes anywhere in the building. So there is a place in which we have all vertical pipes in a building. And that makes the design of this piping system more complicated. But as you can see in REVIT, it's quite easy because working with pipes, the elbows are like this. It's not like the air ducts that the elbow has a very long distance. But here, elbows, T's with pipes, they are very small, and they don't affect the design of the piping system. Okay, so are we done here? No, because there's something missing here. So you see that we have this. This is for the exhaust. Okay, so here, this is a duct. This is not a pipe, and this is something to get rid of. So we have to go up. Can we? No, we can't. Why? Because again, in my version of REVIT, we don't have this for round ducts. So I have to edit type. I have to edit this. Look at this elbow, none. So it has to be the round metered elbow standard, and then T. Okay, that should be enough. Okay, and now on the east elevation. So there is something here that it's not junction. Transition standard and detail standard. Okay, now it works. Sometimes you have to, because if you don't have the right family loaded, then you have to select another family to make the elbow. So if we need to get rid of the smoke, we need this duct. Okay, so now we have all the elements here. We have a boiler, a condensing gas boiler. It's quite good, very efficient, and it's connected to the heating coil of the air handling unit. Great. Then we have the water-cooled chiller connected to the cooling coil of the air handling unit, and the other part of this chiller is connected to the cooling tower. And then we need something to. This is not a closed loop. This is just to get rid of the gases that we are generating here by burning gas. We are generating those gases in the boiler, and we have to get rid of it. And we get rid of it vertically. So there is not an option to have a horizontal pipe and take it to the street. No, this is not an option. We have to go up. Okay. So is this a masterpiece? Well, it's not. But at least everything is connected to the right thing. And that's, but this is not acceptable. I mean, if we're designing something like that and we show this 3D model to the plumber, maybe we are proud of ourselves. Oh, this is my first piping system in REVIT. But it's professionally, this is not acceptable because there are a lot of pipes here, or there are a lot of fittings here that they shouldn't be, and we have a lot of vertical elements in different places. So we have to concentrate all vertical elements on the same place, and sometimes it's very difficult. Okay. But this is enough for the piping system. So I'm going to design very quickly the air diffusers for the supply in the return. But now we know something else. We know that for the air ducts, yeah, now we know this rule of thumb. Okay, so we know that the area is 144 times the airflow divided by the velocity. Or if we want to calculate the velocity, it's 144 times the airflow divided by the area. So both things are correct. Now we are going to, before starting drawing, I want to find out the maximum area that we're going to have here. So this is what we did. If you remember, our airflow was 6,000 CFM, because we had, I don't know the number of people, but we calculated that, and we ended up having 6,000 CFM. We had 4 diffusers, so 6,000 divided by 4 is 100 and, oh no, it was divided by 8. Okay, it was 750 because we have 4 diffusers on the second floor, 4 diffusers on the first floor. Okay, so each diffuser, it's 750 CFM. Total, 6,000 CFM. If we multiply this times 144 divided by the velocity, and why is it 1200? Because for the main duct, the velocity has to be between 800 and 1300. So 1200 is good. So for our main duct, the maximum duct is going to be 720 square inches. So this duct is 26 by 26. We can make it 30 by 30, and it works well. Okay, so the maximum size for this should be 30 by 30. So we can select the air handling unit, we can edit the pipe, and the supply air width, so let's make it 30. Okay, so all these air supply, return, inlet, outlet, let's make it 30, apply. Okay, so this is now 30 by 30. So we can start drawing a duct now. And we know that with this 30 by 30 duct, the velocity will be fine. Okay, so now what do we have to do? Let's start with level 0. So on level 0, we have this, but what we have to do now is to design the air terminals. So we are starting with supply diffusers. Look at this, we have 24 by 24, and the neck is 10. So we can make this calculation beforehand. What is the airflow of supply diffuser? It's 750 CFM. Okay. So now, what is the area? So the area of the last supply diffuser, when we have only 750 CFM, the area will be 144 times 750 divided by, and what is the velocity? The velocity for the branch ducts has to be between 200 and 600. So let's make it 400, for example. Here. So this is divided by 400. So what is this area? The area is, well, I can make it here, 144 times the airflow, 750 divided by 400. So the area is around 270. Square root is 16. Okay, so 16 is the size of this last duct, so that the speed or the velocity is good enough. So what can I do here? Okay, so if we are designing these air terminals, you see that this is the 10 neck. 10 is the diameter of the flexible duct. Can we change it? Yeah, we have here a 16 neck. Okay, so let's use this one. It will be better. And then let's place 1, 2, 3, and 4. I showed you, oh, well, first we need to check the elevation. So the elevation from level, it's 0 now. So let's make it 9. I don't remember if I told you 9 or 10, doesn't matter. Let's make it 9 now. Then we have to annotate. So we annotate this distance, this, and this. Then we click here, and now they all have the same distance. And now on the 3D, yeah, it's good. Okay, so we have diffusers, but now this is, if we draw a duct here, it's a 16-inch duct. It's not 10. So the speed will be good here. What about the duct? So now the minimum duct is 16. The maximum duct is 30. So what is this? So this can be 20. Yeah, so this is 16 and this one is 30. So I think the horizontal duct should be 20 by 20, and we can check if we are doing things right or wrong, but I think 20 will be good. And what am I doing? Oh yeah. So now the duct. Let's use a round duct now, because round ducts are usually better than others, and we want to have it exposed, so round ducts are nicer. But okay, it's default. The diameter is 16. We need something more, so let's make it 20. Okay. So now we have to go this way. By the way, we have to make sure that this is supply air, it's not return, because now we are going to connect supply ducts to supply. Oh, but the elevation, yeah, I think it's too low. So the duct cannot be below the diffuser level. So we need to change the elevation. So let's make it 12. Okay, that's better. And now can we connect this with a flexible duct here? Yes, we can. Nice. Oh, and by the way, we need to declare the CFM. By default, it's 500, but it has to be 750. Okay, so this has to be 750. This has to be 750. And this is 750. Now, can we connect this directly to the duct? Let me try. No. So we need to insert a fitting, but not this one. I need a T. But I need a round T. Okay, round T, this one. Round T, straight, standard. Okay, that's okay, but it's in the other side. I have to rotate it. There you go. And now on the 3D, I hope I will be able to connect those. No, I want a flexible one. There you go. Perfect. And now I have to do the same with the rest of this, so I can insert another fitting. Here, rotate it. There you go. And finally, another T here. And rotate it right. There you go. And now from the 3D, click this, draw flexible duct here, and from this point, flex duct here. Nice. Now I have to check if everything is correct. So the flow, the total flow of this duct should be 750 times 4. And this is 3,000. Yes, I like it. Okay. Well, what's the velocity? Okay, so let me check the velocity. The velocity, it's 1,300. So that velocity is 1,300. That means, is it within the limits? Not really. It should be between 500 and 900 because this is a main branch. So we have to make it a little bigger so we can change this. Let's make it 25. Okay, so now the velocity it's 800. Well, it's getting better. Okay, so now is Revit intelligent enough to connect a round duct to a rectangular duct? So let's find out. No. Well, usually it is, but probably we haven't included the right fitting. But what if we turn this into a round duct and the diameter is 30? Perfect, I like it. Okay, so now we have connected this automatically. Well, this is not the best elbow we can have, but anyway, for this exercise is good enough. And what is the airflow here? The airflow is 3000 and the speed or the velocity is 600. Is 600 within the limit? Yes, it is within the limit, but we need to copy this first. Okay, so if we go to the east elevation, I think we can copy all that stuff, including this. We copy this here. Okay, and now the only thing we have to do is to connect this to this. Well, it works. Okay, so the flow here should be 0. Okay, so there's something wrong here. Probably this connection is not the right one. So let's try to work with the east elevation. Move it up. From this one, I draw a duct. And now the duct here. Oh, it's 0. Oh, now I see. Because there is no diffuser there. Yeah. So I'm copying this diffuser. And now I'm connecting this. Here. And is this now 0? Oh, because I don't have this here. Yeah. There you go. Okay, so now this is 750 and they should be 3,000 and this duct here should be 6,000. Okay, so now everything is correct and we only have to move this here. Yep, and now this duct should be 6,000. There you go. Well, I tried to use a shortcut by copying things and I forgot to copy two diffusers, but anyway, now it's working well. And now we have to do the same with the return. Okay, I think we have time. So let's do it. Go to level 0. I'm going to use air terminals, but now I have to use return diffusers. Oh, they are not here. So I have to insert family, mechanical, MEP, airside, air terminals, and is there return diffuser here? Okay, so return diffuser, open, systems, air terminal, return diffuser, and this is 12 by 12, but I want a 16 neck. Okay, so the neck is the diameter of the flex duct. So this 16, it's good enough. And I can place it here, and here, here, and here. Oh, I have to change this. 750, 750, 750, and 750. And now I have to change the elevation because it's 0, and it has to be, I think this is at 9. Yeah, it was at 9. So I select this, I change the elevation, 9. Okay, great. And now on level 0, I have to do the same. I have to insert a duct. The elevation of the duct, I think it was 12. Okay, and that's interesting because look at this. We can have a conflict between the pipes and the duct. So we have to be careful. Okay, so look at this now. Because now we are going through this duct. So this is unacceptable. So if that happens, probably there would be an issue with the airflows and we have to fix it. But that's what I want you to do this, because now when we have a lot of ducts, pipes and all that stuff, we have to be careful and we have to make sure that we don't have these kind of conflicts here. Okay, so the pipes are pipes, ducts are ducts, and we don't have any intersection between pipes and ducts. And once we have this, we can insert, oh, by the way, that has to be 16. No, I want 20. 1. And now we need fittings. We need that T here, another one here, and another one there. Okay, then with the 3D, we can connect a flex duct here. This is 16, by the way. Yes, it's 16, and the speed or the velocity is 500. Great. So now we connect this here. We connect this here. And there. If you remember this duct, now the speed is 1300, so we have to make it bigger, let's say 25. Yep. And now we have to go up. So on level 15, no, level 30. So we have to go up. And from this now, oh, I have to use the north elevation to go up. A little detail. This is rectangular, so let's make it round. Okay, and then let's go this way. And where is the duct? Okay, it's here. There you go. And now from the top view, I love REVIT. There you go. And we have to check the flow here. It's 0. So where is the mistake? This is 0. This is 0. This is 750. What? Okay. There's something here that's not working about one of those connections that suggest checking and figuring out. Probably it's here, because here we have a weird connection between this pipe and that T. Anyway,